Hi to all. Today we are going to see the concept of classical encryption techniques. This is the chapter 2 in network security. So we are going to see about classical encryption techniques today. So let's go into the topic. First, I explain you about what is called cryptography. Cryptography means by sending the message using an encrypted format. This is called cryptography. For example, in this picture you can see, in other words, what is the main goal of the cryptography is to achieve confidentiality. Confidentiality means no one couldn't able to steal the informations, and the sender and the receiver only share informations. The intruders or hackers couldn't able to intercept the informations or steal the informations is one of the main goal of cryptography. The main goal of the cryptography is, in one word, we can say as confidentiality. Okay. Here the sender name is the Alice and the receiver name is the Bob. Bob. And the sender send an information. My account number is 485853 and my PIN number is 4984. Okay. You people all knew that account number and PIN number is very secret information. So the sender send the message in an encrypted format with a private key to the Bob. Okay. The private key will be shared by both the sender and the receiver. Here, this is the third party called the eavesdropper. The work of the eavesdropper is just that's to want to steal the informations and hear the informations, what or travel in between the channel and all the things. Okay, this is called the cryptography. By sending the message in the encrypted format, the sender send the message, send the plain text into the encrypted text by the use of the private key or a public key. At the same time, the reverse process was held in the receiver's side. The encrypted text was decrypted into the plain text by the use of the private key or public key. Okay. The private key will be shared only by the two, the sender and the receiver, not known to all. Okay. Message here is sent in clear. Eve can overhear the message. Encryption unintelligible to Eve. Only Bob can decipher with his secret key, because Eve does not have the key, so only Bob will receive the message by using his secret key. Okay. So this is the first concept here I am going to explain is the symmetric encryption. There are two types of encryption. One is the symmetric, one is asymmetric encryption. Here this is the symmetric means symmetric encryption, also referred to as conventional encryption or single key encryption. Here you can use only a single key and was the only the type of encryption is used prior to the development of the public key encryption in 1970s. And the symmetric key encryption was used before the public key encryption was developed. In 1970s it was used. In this chapter, we begin the look at a general model for the symmetric encryption process. This will enable us to understand the context within which the algorithms are used. Next, we can examine the variety of algorithms in use before the computer era. Finally, we look at briefly different approach known as steganography. So, the second chapter covers these three content only. First, we are going to see about symmetric encryption process, that is single key encryption. So this is the concept of symmetric encryption. Here we choose the two persons, the one is Alice and another one is a Bob. Alice encrypt a message with the same key that Bob uses to decrypt. Okay, you can understand. Can you understand, guys? Because Alice is the sender, Bob is the receiver. Alice send the plain text with encrypted. Alice send the plain text by in the encrypted format by the use of a key and sent to the channel. The receiver also open or decrypt the message by using that same key only. Okay, that is called the symmetric encryption. Both the sender and the receiver uses the same key. Here you can see allies construct a message. This is the message, plain message, and compute the message by using a key. This is the private key. This is the algorithm that encrypt the message. F is the function and also called as the algorithm that encrypt the message with a private key. Send the message C to Bob. Okay, so the C means this one, message and key. Sent to the receiver. In the receiving side, receive C from the allies and decompute here, because D refers to decompute, F inverse because the process was reverse the process here. This is called the cipher text. Cipher text or the C, cipher text comma key. So here this one is the same, here this one is key. So finally have received this C equal to M. M means the sender send the message M. Here the cipher text, if those are equal, then that is the message was received successfully to the receiver. Eve can see C. Eavesdropper can see the message C, but cannot compute M because K is only known to allies and Bob. Okay. Keep it in mind. I repeat this once again. This is the message, computed message or encrypted message. This encrypted message was sent to Bob, but the eavesdropper or an opponent can see the message C, but he cannot able to compute the value M, message M, because allies and Bob share a common key called K. Here the eavesdropper couldn't know the key, so he cannot able to see them. He cannot able to compute the message, original message. Okay. So here you can see what are the two types of ciphers. One is the symmetric cipher. I explained before. Symmetric cipher means it uses this sender and the receiver uses the common key, the same key used for encryption and decryption. In other words, you can say same key used for both encryption and decryption. Here there are many types of symmetric cipher. Here in my further classes I will explain you about what are the types of symmetric cipher. Here just two examples are shown, block cipher and stream cipher. Then second one is the asymmetric cipher. In the name itself, it uses different keys used for encryption and decryption. So this is the introduction of symmetric encryption. Here we start with what is plain text. Plain text means the original message. The sender want to send a message, that is called the original message or plain text. Then what is meant by cipher text? The plain text were converted into a coded message, that is called the cipher text. And then enciphering on encryption. What is meant by encryption is the process of converting from plain text to cipher text. Okay. The process of converting plain text to cipher text. This is called encryption. And deciphering or decryption. This is the reverse process. The process of restoring the plain text from the cipher text. Otherwise, the process of converting cipher text to plain text is called decryption. Okay, there are many schemes used for encryption, constitute the area of known as cryptography. Such a scheme is known as cipher. Techniques used for deciphering a message without any knowledge of the enciphering details fall into the area of cryptanalysis. Because the sender send the message through in encryption format, the intruders want to steal the message. That means deciphering the message. That's called the cryptanalysis. So cryptanalysis is what the layperson calls breaking the code. The area of cryptography and cryptanalysis together called cryptology. So this is the symmetric cipher model. A symmetric encryption scheme has 5 ingredients. The first one is the plain text. The plain text is the original message, original intelligible message or data that is fed into the algorithm as input. The plain text is given as input to the algorithm. encryption algorithm, and the encryption algorithm performs various substitutions and transformations on plain text. And then the third one is secret key. The secret key is also input to the encryption algorithm. The algorithm will produce a different output depending upon the specific key begin used at that time. Okay. The exact substitution and transformation performed by the algorithm depend upon the key. The secret key is one of the important concept in this encryption algorithm. The fourth one is the cipher text. This is the scrambled message produced as output. It's depend upon the plain text and secret key. Okay, the plain text was converted into ciphertext with the help of secret key. Two different keys will produce two different ciphertext. Okay, the plain text was converted into ciphertext according to the secret key only. So, two different keys will produce two different ciphertext. The ciphertext is an apparently random stream of data. Once again, I repeat this: the ciphertext is an apparently random stream of data. The last one is decryption algorithm. This is essentially the encryption algorithm run is reverse. It takes the ciphertext and the secret key and produces the original plain text. Okay. It takes the ciphertext and the secret key and produces the original plain text. These are all the 5 components in a symmetric cipher model. So this is in the picture you can see this is the plain text that is called the X. This is the encryption algorithm. This is the secret key. The plain text was given as the input to this encryption algorithm with the use of the secret key. This key was shared by both the sender and the recipient or receiver. This is the y is the output y equal to encryption E. What encryption taken here is with the plain text and the key. This is called the K key, secret key, and the plain text X. Okay, this is the ciphertext. Y has the ciphertext. It was traveled to the receiver. In the receiver side, decryption algorithm was happened, reverse of encryption algorithm. So here this is the plain text. So the receiver get only the plain text. So Y is the encrypted text, X is the plain text. So X equal to decryption algorithm D. Secret key. The secret key was used the same by the sender and the receiver. This is the ciphertext Y. Okay. They get the plain text as the output. Okay. Once again, I explain this. This is the model of a simplified model of symmetric encryption. This is the plain text the sender want to send. That the plain text is noted as X. Okay. This was the plain text was given as the input to the encryption algorithm. Example AES. By the encryption algorithm by the use of the secret key. The secret key was shared by both the sender, this receiver. Okay. This is Y is called the ciphertext. Ciphertext equal to encryption algorithm, secret key K, encryption algorithm E, secret key K, and the plain text X. This was traveled to the channel and sent to the receiver. In the receiving side, the decryption algorithm was working by the use of the same secret key K. Okay. This is the secret key that was shared by the receiving or receiver too. This is X is called the plain text equal to decryption algorithm D, the same secret key K, and the ciphertext Y. This was converted into the plain text. Okay, this is how the symmetric encryption was working. So another example here, Alice sent a message that was encrypted. Encrypted means it is in the different formation to the Bob. Here the key was shared by both the Bob and the Alice. Okay, so Alice here the Bob sent a message to Alice. Okay, so encrypted message. This is the 6CB6. This is called the encrypted message sent to Alice. Alice decrypted the encrypted message with the use of the same secret key and get the message. The message here transferred is hello Alice. Okay. Bob sent a message hello Alice to Alice. This is sent as the encrypted format by using the secret key. Here Alice decrypt the encrypted message and he received the message hello us, hello allies. Okay, here this is called the secret key. In